Hey everyone, and welcome to This Explainer. Today, we're diving into a massive, absolute mystery that we've all faced. Automated pipelines that lie to us. You totally know the feeling, right? You push your code, wait around for the checks to run, and everything lights up a beautiful, reassuring green. But is your code actually bug-free, or did your continuous integration pipeline just completely fail to test anything at all?
Okay, let's dive into this. Picture this terrifying yet totally familiar reality. Your CI pipeline confidently states, all checks passed. The code linting took maybe 4 seconds, testing took 8. You merge your pull request with absolute total confidence. But then you look at your production environment and it is completely broken. Users are getting errors. So how exactly does a perfectly green pipeline ship critical failures? Well, the pipeline doesn't inherently lie. It just reports on exactly what we tell it to do.
And right here is the culprit. 0 tests ran, exit code 0. This is the mystery of the silent failure. Maybe you configured the wrong test path, or you had a missing test file. In tools like the Python framework PyTest, if it doesn't find any tests, it literally just shrugs, reports nothing, and exits with a success code of 0. Your pipeline goes green because it successfully failed to test anything at all. Production is broken, but hey, your pipeline looks great. Honestly, this happens way more often than any of us want to admit. So here's our roadmap for today's explainer. We're going step by step to lock down your CI, fixing base configuration, speeding up matrix builds, test reporting, the fail-fast order, and local CI parity. Section 1, fixing base configuration, or, as I like to call it, tests that actually mean something. Okay, the crucial point here is configuring our testing tools to loudly fail when nothing runs. For those new to setting this up, here are the essential flags you need in your project configuration. First, define test paths equals app. This explicitly tells your testing tool exactly where to look. No more empty directory scans that silently pass. Second, use --strict markers. If you make a typo in a test marker, instead of silently skipping it, this flag forces an immediate failure. And finally, -tbshort gives us a concise error summary, keeping our CI logs actually readable. This is your first layer of security against silent failures. Moving right along to Section 2, speeding up matrix builds. Now, this brilliantly illustrates the sheer power of a matrix strategy for reducing execution time. Let's say your app needs to support different operating systems, like Ubuntu and macOS, and different Python versions like 3.10, 3.11, and 3.12. Instead of running these tests sequentially, one after the other, and waiting around all day, a matrix build runs the exact same test job across every single combination simultaneously in totally parallel pipelines. 6. That is the number of concurrent jobs we get from just 5 simple lines of YAML configuration. 3 Python versions multiplied by 2 operating systems. By running all 6 of these in parallel, we radically reduce developer wait time and find out incredibly fast if our app breaks on one specific system configuration. It's a real game changer. Now, what's really interesting about this slide is this specific setting, fail fast false. By default, if just one job in a matrix fails, GitHub Actions instantly cancels all the remaining jobs. But for proper CI feedback, that default behavior is actually dangerous. We want to see all the failures across our matrix, not just the first one that tripped up. Setting fail fast false ensures that if your code fails on macOS, the Ubuntu jobs keep running, giving you a complete, accurate picture of your bugs. All right, Section 3, test reporting and coverage. So how do we actually surface these failures so we don't have to waste time reading raw logs? 3 best practices. First, use the -unit XML flag. This converts raw test output into machine-readable XML, which GitHub uses to show the exact failure inline right in your pull request. Second, -cov fail under 80. This establishes a hard coverage threshold. If coverage drops below 80%, the pipeline blocks the merge, preventing your test coverage from silently degrading. Finally, when uploading test artifacts, you absolutely must use the if-always condition. Without it, artifacts only upload on a success, meaning you wouldn't get your failure reports when you actually need them to troubleshoot. Next up, Section 4, the fail fast OR. Let's see how this builds a highly efficient pipeline. Remember, pipeline time is money. We need to sequence our checks to fail fast. Look at this sequence. Step 1, static checks for syntax errors. They cost almost nothing and finish in seconds. Step 2, linting for style, maybe 20 seconds. Step 3, unit tests, testing logic, taking a minute. Step 4, integration tests, verifying complex interactions before they reach production, which can take up to 5 minutes. The strategy is so simple. Run the cheapest checks first, Don't spin up heavy, expensive databases for an integration test if you just have a typo that a 2-second static check could have caught. And we can optimize this even further and stop wasting time with a couple more commands. First, dash max fail equals 3. If 3 tests fail, just stop the run immediately. If a broken import breaks 50 tests at once, you don't need all 50 cluttering your log. You just need the first 3 to know you have a systemic issue. Second, dash timeout equals 30. This automatically fails any test that hangs for more than 30 seconds. One stuck external API call should not block your entire CI pipeline for 10 minutes. These configs keep your feedback loops incredibly short. And finally, Section 5, Local CI Parity. Let's look at troubleshooting arguably the most classic, frustrating developer headache ever. Why does it pass locally but fail in CI? Your local tests are perfectly green, the pipeline is red, nobody knows why, and your pull request is just stuck in absolute limbo. The absolute #1 culprit for this headache? Unpinned dependencies. If you just specify your dependency loosely, a pipeline running at 9 a.m. might get one version, but at 3 p.m., it silently grabs a newly released background update. Not only is this a nightmare for CI parity, but it's a massive security vulnerability if that update contains malicious code. The secure solution is to pin everything. Using exact versions guarantees deterministic, reproducible builds every single time. You upgrade intentionally, not accidentally based on the time of day. The second vital piece of this parity puzzle is what we call makefile parity. Basically, you create a local script, like a makefile, to ensure the exact same test commands, flags, and rules run on your laptop as they do in the cloud. When a developer runs make tests locally, it triggers the exact same strict markers, coverage rules, and environment variables, the whole shebang. If CI fails, you can reproduce it locally instantly with one single command. Well, we've covered a ton of ground in this explainer today, from stopping silent failures to speeding things up with parallel matrix builds. And it all leads back to this core philosophy. The pipeline either passes rigorously or it fails loudly and immediately. There is absolutely no middle ground. So I'll leave you with this question. Is your team's pipeline actually catching bugs, or is it just generating a comforting automated lie? Apply these configurations today, stop those silent failures, and ship with actual confidence. Thanks for joining me, and I'll see you on the next explainer.